Hello everyone, let us discuss the Codechef problem layered cake. There is a chef and he is trying to make a cake which consists of two layers. He has n number of options for the first layer given as an array A1 to An, where A of I represents size of the first layer. He also has m number of options for the second layer given as an B array B1 to Bm, where B of j represents size of the second layer. There is a condition that the second layer is strictly smaller than the first layer. So in order to make a cake, we choose a value from the first layer and we choose a value from the second layer which satisfies the condition and form a pair of ai, bj. As you visualize here, this is the first layer and this is the second layer. The goal of the current problem is to find maximum number of possible pairs which satisfies this condition. Let us understand by a simple example. Let's take an array A of 4, 3, 8 and array B of 6, 2 and 1. So, we list out the possible pairs. If we choose 4 as the first layer, the second layer must be smaller than the first layer. The possible pairs would be 4, 2 and 4, 1. If we choose 3 as the first layer, the possible pairs are 2 and 1. Similarly, if we choose first layer as 8, the possible pairs would be 8, 6, 8, 2 and 8, 1. Now you people are able to identify the possible pairs and the total possible pairs are 7 pairs. What we are doing here, for every first layer, we are trying out all the second layer options, and wherever the condition B of j is less than A of I, we are considering that pair and we are incrementing the count. For this is a brute force approach that for every value in the array, we are trying all second layers. Whenever the condition is true, we are incrementing the count. So this runs for order of n times. For every n, this inner loop runs order of m times. So the time complexity for this problem will be order of n into m. The constraints of the problem is 1 less than t less than 100 and the nm values are also up to 10 square and the ai bj values are up to 100. If we calculate the time complexity considering the constraints, then it would be order of 10 power 4. If we consider the number of test cases, order of 10 power 6, which is efficient for this problem. We can also explore the optimal solution for this. Let us take an example of other arrays. 8, 13, 4 and 12. And the B array is 6, 2, 1 and 10. Let us sort both the arrays and see how sorting helps us. The sorted array now becomes 4, 8, 12 and 13. And array B becomes 1, 2, 6 and 10. We'll write the index numbers for the better visualization. we follow a two-pointer approach to consider the valid pairs. The condition is b of j is less than a of I. We initially start with I equal to 0 and j equal to 0. For the first layer 4, what are the possible pairs? 4, 1 and 4, 2. We keep on incrementing the j pointer until this condition gets false. So here the 2 is less than 4. So it is true and we'll increment the j. And the valid pairs are 4, 1 and 4, 2. Now we stop exploring this 4 and we go to 8 and we compare from the current j. Why this happens is, if 1 and 2 are less than 4, then I can say 1 and 2 are less than 8. So we, without explicitly exploring all the possible pairs of second layers, we directly add the number of pairs which are considerable for these both. So we'll add 8, 1 and 8, 2. Now 6 is less than 8. Now we'll increment this j pointer. Now the conditions gets false. Now we'll stop. Now we'll stop and we'll move to the next first layer. 12. We'll compare. Is 10 less than 12? Yes. We'll increment this j pointer. And we'll go to next possible first layer. As there are no second layers, we again consider the possible pairs which are friend to the j. Now the possible pairs are 12, 1, 12, 2, 12, 6, 12, 10. And for 13 also I can consider the pairs which are friend. So the approach is, we initially sorted the array A and sorted the array B. We took two pointers which is I is 0 and j is 0. For every value in array A, while j is less than m and b of j is less than array of I, we incremented the j pointer. And when this condition gets false, we can simply add the number of pairs we found. After this, we can return the count. The time complexity of this is, if we carefully observe, we are not exploring every second layer. We are exploring from the current j pointer. So the time complexity of this approach is order of n plus m. Thank you.